So I titled this, Welcome Java ME into Your Everyday Life. And the reason why we created this event and structured it the way we have was because we wanted to give you an update on the entire spread of the Java platform. Not only one part, we wanted to do the whole range. So the first talk, real talk, is about Java ME. Then we're going to do web tier, then we're going to do enterprise tier, and then we're going to move on to server and things like that. So Java ME really has become a part of everybody's life, and you may not have realised it, but Java ME is in your pocket on your mobile phone. Not only is it in your pocket on your mobile phone, it's on your home entertainment system. Not only is it in your home entertainment system, it could be in your car. It could be on your badge. As they were talking about Sunrays this morning, this is my Sunray badge. Not only is it my Sunray badge, I can buy food with it. Not only can I buy food with it, I can get into doors with it. So don't steal it. So I'm just going to cover a few things here. Java ME update. I should go back a slide really. Java ME update. New and future APIs. A bit about wireless gaming. I did a presentation at the gaming conference recently, and I find it quite exciting. I'm sure you will too. A bit about the Java gaming server. And that's an interesting one because Sun's not a gaming company. So I'll tell you a bit more about that. Cover a bit more about the mobile tools, what's available to you from a mobile standpoint, and then talk about some resources. So what are the advantages of Java ME? So Java ME is Java. So all the benefits of Java applies to Micro Edition. And some people say, well, the principle of write once, run anywhere is not really true. We've got problems, we've got bugs, we've got inconsistencies. Sure you have, but try and do the same thing in C. Try and do the same thing in .NET. I'd love to see somebody take a .NET application and run on Mac OS. You can't. So, you know, we tried the best to achieve the right ones run everywhere. It's almost there. It's never going to be perfect. One developer said to me, well, we wrote an application, we installed it on a Sony Ericsson phone. I took it to my Nokia phone, and my Nokia phone had a memory leak. So I couldn't use it. It's Java's fault. Well, actually, no, it's not Java's fault, it was Nokia's fault, or whoever it was, because they didn't test their suite properly. We're trying to work with these mobile providers to make sure that we have better test harnesses. We try and catch as many problems as we can to really bring home the true right ones run anywhere. Security is a big thing, and it's become even more apparent now in the browser wars, in the operating system wars, in the number of security breaches, the number of patches that are released. I know Microsoft has its is it third week of the month, every Wednesday or something, patch release cycle, and if it has urgent patches, it releases them earlier and all that sort of stuff. Really important now, security. Solaris is, you know, the secure operating system, always has been. It's government accredited in the United States and around the world. We trusted Solaris, and we're moving those now into the mainstream. And Java from the beginning has been secure inherently with its permissions architecture, with you know, the signing, just the way it's architected from bottom upwards, and that applies to the ME world as well. And that's really important because if you've got your Java card, you don't want to start being able to put an application on here and pretend you're someone else, or edit the application that's on there to say that I have 10,000 euros to spend on food. You don't want to start doing all that sort of stuff. And it's the same with the mobile phones. if you've got a mobile phone, you don't want to start walking up to the metro station and saying, you know, I've got 10,000 euros worth of credit, let me on every train possible. So security is very important, and Java ME provides that security. Rich set of APIs. You can now do gaming, 3D gaming, using OpenGL, using your mobile phone. You can move from a 1 GHz CPU to a 10 GHz CPU, and it will still run, and it will run better. So the APIs that are available to you now are more and more, and it's become really useful to have those things to be able to write some really rich applications. So the momentum, some marketing slides coming up. Huge. This is 2004, 2005. You can see here that there are 708 million mobile phones with Java on it right now. More than 7 out of 10 mobile phones ship with Java on it. And the increase is just phenomenal. And these are just not Sun's figures, these come from OVO, from Nokia, and Sun as well, the number of handset models. And it's just incredible. And these are latest figures from around February this year that I put together just to show you what's been happening since 2005. 84% increase in the number of handset models since 2005. 50% increase in units installed base. Nearly 1,000 million, over 1,000 million handsets out there with Java. So if you're not thinking about mobile applications, maybe you should, because we're really living in a mobile world now, and if your application is purely web tier or it's purely enterprise tier, you want to start thinking, well, how can I bring that to my mobile? How can I open up my potential market? And this market is huge. This is billions and billions of dollars worth of market. One of the things that you mentioned structs earlier, Java Server Faces allows you to have resource kits. Those resource kits allows you to define a mobile device. So WML and so on, SVGs, the scalable vector graphics, all that sort of stuff. So you can write a web tier application with views and things like that, but have it run on your mobile phone. And then you're open to this massive market, which is huge, it's phenomenal. So it's something you really can't ignore. And the last point there is the number of shipments with Java has gone up. So we've got 84% increase in number of models. We've got a 50% increase in the units mobile phones shipped, and there's been an increase of Java on those mobile phones. So, in wireless gaming, how popular is Java? Number one in volume, by a long way. But it's not just about the number of people writing games for Java. It's also about the content. It's fine if you've got Java on every mobile phone and a game on every mobile phone, but how good is that game? Is that game good? Or would it be better or worse than .NET? No. Number one in content, the quality of the application. And this, I believe this comes from Wireless Gaming Review, and it's a public vote, basically. And you can see they're number one in deployments as well. So you've got some big carriers there, Vodafone in the UK, Orange in the UK, and some massive deployments of Java and provisioning of Java mobile applications. So among mobile phone developers, it's the number one platform too. And it's growing. Java ME was up, .NET was down, Series 60 is up, and Brew was up too. but by far it's growing. And the tools are getting better, so we expect that to carry on growing. So I wanted just to touch on Java in the home because this is quite a really cool and interesting area that is going to affect us all. So the mobile phones are affecting us all, and Java in the home is going to start affecting us all. Now I know in France there's quite a lot of development. Orange is a large development centre here, and there's plenty of other ME developers in France. And digital video broadcasting. Who's heard of DVB? You may notice the logo. I didn't really know who they were until quite recently, when I recognised the logo because it's on all of my digital appliances under my television. And I didn't know that in 1998 they mandated in the specifications that they would use Java. I didn't know that, but that's pretty incredible. So digital video broadcasting, if you don't know, is a worldwide open standards consortium who deal with digital television and digital media around the world. And there are around, I think it was something like 300 countries right now signed up to participate in this open standards consortium and set the standards for digital television. So what they've defined is this thing called the multimedia home platform. Basically what it is the middleware between the transmission and the box. So if the box is running, I don't know, a PowerPC chip, maybe it's running an Alpha chip or Intel or AMD or whatever chip it's running, whatever OS it's running, whether it's running Linux, whether it's running BSD, whether it's running Windows, whether it's running Mac OS, whatever you want to run on your set-top box. The multimedia home platform mandates you to the use of Java. It's the software and the APIs that allow content providers to write applications and interact with the media to be able to become platform neutral, which is how Java became such a good fit. So the globally executable mobile multimedia home platform called GEM is basically the same as the multimedia home platform, but it's transport neutral, so you can use any transport around the world. And this slide's a little bit out of place. So DVB is the worldwide provider and setter of standards. MHP, like I said, is the middleware stack, which is all the applications and the program. The GEM is the transport neutral, so it can be used around the world. So OCAP is the American, what is that? That's the American cable standards, and this one is the terrestrial standards for America. The ARIB V23 is the Japanese version of digital, and Blu-Ray. I'm sure many of you have heard about Blu-Ray and HD DVD. Blu-Ray inherits from the transport neutral mobile home platform. And the reason why it does that is because Java has been so successful on that multimedia home platform by what they call Java TV, by streaming video, controlling the video, dealing with all the streams and the security and the provisioning and things like that. But Blu-ray said, well, why don't we use the standards already that have been set? This is a worldwide standard. Why don't we use those standards? Which is why we now see Java being mandated in Blu-ray players. What does that mean to you? So that means, well, you You're probably going to see it on a PlayStation 3. I don't know, I've not got one, but I like one. You're probably going to see it on all your Blu-Ray DVD players. And if any of you got to Java 1 last year, you would have seen that there were some Blu-Ray DVD players actually at the show. And they were showing, I think it was Mission Impossible 3 or something like that. And they had some really cool stuff they were showing. So what does it give you? I mean, so what? It's got Java on the box. What does it mean to you? It's going to be a richer integration. So you can now get layered graphic screens written in Java that overlay the video. You can get different bits of video in different parts of the disk. So on DVD right now, if you want, for example, a piece of video on your index, you have to actually copy that video into a different part of the disk. And if you copy that into a different part of the disk, you're going to lose a whole bunch of space, which compromises the quality of the film because you've only got a limited amount of space. With Blu-ray, it doesn't copy the video at all. It just references that piece of video. And then Java can be used to create the GUI, the screens, and manipulate the video and play around with it and things like that. So you're going to really see more hands-on approach, and so it's going to be more interactive with Java. So the features, the special features. One of the things that Blu-ray and the global MHP specifications say is that you may have an internet connection. So you can test for an internet connection. And that's quite cool because when you put your disk into the drive, you should be able to, you may be able to access the internet. If you can access the internet, you can start downloading content afterwards. So if I gave you a DVD, the same day it was released in Japan, the same day it was released in America, but there were no French subtitles, there was no French audio, and you didn't speak English, you've just spent, 20 euros on a DVD which could be useless to you. But if you got on the net, you see the content providers then can supply you with the subtitles, they can supply you with the audio, they can supply you with games, they can supply you with links, they can supply you with extra features, extra bits of video. The size of MP4 these days, I mean, it's so small for the quality you're getting. You can just stream any video off the net, and these are the special features that this Java stack's going to give you. So new business models. Well, if you've got an internet connection, you've got all this content on the DVD, you've opened up a whole new market. You can start selling things on DVDs, whether it be magazine subscriptions, whether it be trailers. Maybe you want to download the trailer and send it to your friend on his iPod or something. And you can charge for that. And there's lots of things you can charge for and create new business models. I don't know, maybe you want to link it up with eBay somehow. I don't know. It opens up a whole new world of possibilities. So that's sort of where Java is going for the mobile space. I hope everyone's familiar with this diagram. So, if everyone knows about mobile stuff, basically there are two API sets of the mobile edition. One of them is for limited devices, one of them is for bigger devices. So the limited devices are something that mobile phones have, and the connected CDC, the device configurations, is kind of what you see on the set-top box. Maybe it's got a stronger processor and graphics and things like that. And so the API sets of those two are quite different. The Blu-ray specification sits on top of the personal basis profile on the CDC side. And all the mobile stuff happens on the CLDC side. So right now, in terms of evolution, we are moving towards what's called MSA, which is the Mobile Services Architecture. And this is basically a richer set of APIs that allow you to do new business, new graphics, new interaction, new sound, and all those sort of things. And we're slowly moving towards that in 2006. In 2007 and 2008, we start seeing those features being rolled out onto the desktop boxes, on the set-top boxes. So the Mobile Services Architecture, this is what it gives you. These are the APIs. And as with all of Java and all the APIs in Java, it's all controlled by the community. Everything is controlled by the community. So Java Server, the specification request, it's all a community process. It's all about companies being involved, setting the scene, setting the APIs, setting the functionalities. And this is how we get all these rich requests, rich APIs. And you can see there's a whole bunch that are really interesting. SIP, Bluetooth, MMS, payment, web services, the location-based APIs which I showed you earlier, the JSL 179. And there's a whole bunch more. They're all going to be released later in 2006. You can use most of them now in sort of early access. And these are the APIs that are not set for any particular target yet, but are on the cards to be released. So there's contactless communication. That's an interesting one. So you walk past the metro station, it might automatically just charge your mobile phone. Mobile broadcast, OpenGL, extensions, and there's service-oriented architectures, and a whole bunch more that's coming. So if you go to jcp.org, you can actually see what these are all about and actually participate. Some of the cool things, scalable 2D vectors. You should know what they're all about, and it's great because when you've got maps, when you've got graphics that are targeting different devices, different screen sizes, you don't have to rewrite your application because they will scale. Location-based services, so I showed you that earlier. There's some examples here advise users of current traffic conditions. So if you're driving down the highway or the motorway, you can find out, if there's traffic coming up, your mobile phone can tell you. Help you find nearby restaurants. So I'll just skip over these because I think you get the idea of what location-based services are. It tells you what's around you, where you are, how do you go places. These are just some terminologies. Wireless gaming. So do you have any gamers in the audience? Any wireless gamers? A few of you, okay? So wireless gaming is, and wireless development, as it says, is limited by the processing power, the memory, the feature set of the mobile phones. When you go from one mobile phone to another, it may be different. The application size is a worry. Technologies just change every day. Somebody releases a new mobile phone with some new thing that everybody wants. And the other thing that's interesting is that with a mobile phone you can ring at any time. So if you're in the middle of filing your taxes or playing Doom or whatever you have on your mobile phone, it can ring and it can mess up your game. So you've got to take that into account. So here are some characteristics that, with a wireless game that you must be aware of. So short playtime. Generally people use them on the train, or they use them, say driving home, but probably not. They use it maybe, you know, just while they're sitting with their friends, I don't know, playing around with their friends, around their friend's house, playing the games and so on. They may be online, they may be offline. The gameplay is probably going to be slower. They're not going to be sitting there like an arcade machine, like bang, 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 like full screen, full speed. They're kind of probably a little bit slower because the CPU is quite slow, and so on. And so obviously there's some ideas there of what you should be aware of. So again, mobile phone devices, you know, are social devices. You kind of use your mobile phone to talk to people, to interact with people, to communicate with people. And this is kind of what you want it to do. So you have to think, if you're making a game, maybe you want to do the same. You know, communicate with people, play with people, make it networkable, and so on. So right now you have a single-player game, a multiplayer game, and connected game. So connected game is basically on the network. Single-player game is off the network. A multiplayer game could be network-based, and you know, you maybe download it from the network and things like that. So there's lots of communication protocols you can use. If you're developing these applications, the more you use the better, because the operators will love you for getting the users to spend their money on mobile phones. I don't know what the statistics are, but in my view, you find a lot of these early teenagers, sort of 12, 13-year-olds, who spend the most time and the most money on these games. I don't know where they get their money from. I guess their parents, but obviously, you know, if you start using HTTP over GPRS, you may be looking at higher costs. So if you're creating a game or a wireless application, you've obviously got to bear that in mind. It's just a comparison between HTTP, SMS, MMS messaging, or Bluetooth. It's whatever choice is right for you. If you know you need a lot of streaming, maybe you should go for HTTP. If it's one-off updates, maybe you can go for MMS or SMS or CDS. Or, you know, if it's just one-off transfer, or you want to sort of do it in proximity, you can use Bluetooth. So another cool thing is the inbound connections. Now that MIDP2 can actually respond to an incoming request, so things can pop up on your mobile phone. And that's pretty cool because, for example, if you have a chat application or something, it can pop up on your mobile phone and say, hey, you know, Bob wants to talk with you. And it can pop up and respond to things. And one example here is chess. So if you're on the train to south of France, you're playing chess with somebody, but they're not on the train, they're with their wife at home. You know, they're not going to want to sit there and start playing chess with you. They probably want to wait for your move. Once you've moved, they will move when they're ready. You know, they may need to pop to the bathroom or whatever they need to do. They don't want to have to respond quickly. So this allows you to do that. So you move, it tells the other mobile phone, hey, he's moved. And then in his own time, he can move. And so on. So I'm going to speed through this now. So we have 2D games. 2D games is really easy because it really takes you back to sort of basic programming language type principles. This is, if you know AWT and Java graphics, you'll know that you have a canvas of object graphics and images, and basically all this does, it extends those sort of things to give you the management that you need. So you have background layers, and you have sprites. Going back, 20 years basically, but you get it on these mobile devices now. And it's really simple, but it's really powerful. So you create, an image with lots of repeatable, transformable graphics that you can spin around and make them look like different things. and you can have collision zones and things like that. So that's Java 2D. Java 3D is slightly more complex, and the beauty of Java 3D is that you can split the graphics side of things with the gameplay. So one person can do all the graphics, your graphics designer, and another person can write the game logic. So this is just, I'm not really sure what this is trying to say, but basically it means your MIDlet writes the mobile 3D graphics, and it doesn't matter what graphics hardware is underneath. So there's three key classes. One is the graphics 3D content, the world, and the loader. So the loader will load the world, and the world will draw the screen using graphics 3D. The world will draw the screen using a camera, so it uses a viewport, and that viewport you can define in the world. And I'll show you an example in a second. So you have retain mode and immediate mode. Retain mode is based on graphics packages, and you can create using something like 3D Studio Max or one of the other packages. Immediate mode allows you to actually program the graphics directly, and you can mix and match them too. So a scene graph is basically what 3D Studio Max creates, and it's just a hierarchy of objects. And it defines things like cameras, it defines things like landscapes and fog. And there's an example. So you have sprites and groups, you have meshes, you have cameras, lights, everything you would expect from a 3D game. So the world node has the backgrounds, the cameras, the lights, the fogs, and everything that composes the world as you know it. And you have to set an active camera to view anything in that world. It uses M3G format, which all the popular 3D modeling packages use. Again, you can use anti-aliasing, dithering, true colouring, and things like that, but it obviously depends on the power of your mobile phone. If your mobile phone can do those sort of things, then great. You may want to turn those off if you're trying to target, lesser known mobile phones or not so current mobile phones. Quick graphic about where graphics 3D fits, how it binds to current the MIDP2 stack. Java games. Okay, I'm well out of time here. So let me zip through this. Where are the games right now? So the games are everywhere. You may have the same game on your mobile phone as you do on your Nintendo, on your PS, on your PC. And they all talk to their own servers. They all talk to a whole bunch of stack of servers in each provider's place, whether it's Orange, whether it's Nintendo's, whether it's Sony's, whether it's just a generic PC. We think this is the way it's going to go. You're going to have one set of servers sharing CPUs, sharing resources, sharing memory, sharing storage, sharing applications. That will provision to every device. It's a lot cheaper, it's a lot more efficient, it's a lot more effective. So we have entered the gaming market, but we're not a gaming company. And we've done that with a project called Darkstar. And Darkstar is a gaming server that is basically going to bring success to the online gaming market. Right now it costs around $10 million to write a single player game. It costs around $30 million to write a multiplayer game. There have been multiplayer games that have failed. And that's $30 million of somebody's money, or people's money, that has gone down the drain because they failed. And this was last year. The reason why they have failed is because they haven't been able to address issues such as latency, such as failover, such as crashing, and so on. And Sun is not a gaming company, but its servers and its software are reliable. We have failover, we have fault tolerance, backups, the whole thing, with the software stack right down to the hardware. So we can use that to our advantage in a gaming server, in the fact that we can provide all of Sun's knowledge of hardware and software to be successful with games. So it talks about the architecture. There are lots of things you need to be aware of when creating sort of game architecture. Because if, for example, there was a recent one, I think it was an EverQuest game that it took days and days and days to kill this huge dragon, and it takes a lot of people to do that, and they're spending money on it. And they're killing this dragon, and they almost killed it, and the server crashed. So what happened when they brought back up the server? The dragon was alive again, full health. So, there's a lot of things that need to be taken into account when you're doing this sort of thing. Darkstar architecture is a 3-tier system based on Java. Communications tier, game logic tier, and object store. So, being Java, you can use any communications, any devices, any programming language. Actually, the APIs provide C, Java, and mobile as well. Basically, the game logic engine can run on a number of servers. It has full failover. It's actually, the object store is 99 and 5 nines fault tolerant. So that's something like, it's something like 1 minute in a year that it will be down. And, so all of this together works really, really well. So you can have failover and the games continue playing. Because the object store is shared, if that server goes down, you can carry on playing. There's no loss of time, there's no lag. It can load balance as well. Not only can it load balance across servers, and any server can take the request, it can distribute itself across CPUs. Not only can the game engine hold one game, it can hold multiple games. So, for example, you don't need a whole rack of servers for one game that's sitting idle because nobody's playing it, and another rack of servers for another game because everybody's playing it. You have one rack of servers, and they can have both games running on one server and share the resources to maximise your investment, maximise your power costs, maximise your air conditioning costs, etc., etc. So that's the gaming server. Right now you can download the SDK, the development kit. It was announced at the Games Developer Conference last month, actually. You can download the development kit and start developing games and sort of getting it in-house and playing with it. You may know other gaming engines such as GameSpy and a whole bunch of others. They don't do what this does. They're really limited to around 5 or 16 players. This is scalable. We're talking thousands of players with all the benefits I've talked about. So, one quick minute on the tools. Java Wireless Toolkit. This is the test harness I was talking about. It allows you to package up your application and manage your Java ME application, have a look at the network, have a look at the memory, things like that. NetBeans 5, as I showed you earlier in the demo, allows you to visually see things, and it uses the wireless toolkit, but you don't need NetBeans with the wireless toolkit. Just some figures basically telling you what the latest toolkit can do: MIDP2, CLDC 1.1, location API, security and trust services, all those APIs I talked about earlier, mobile 3D. Wireless Toolkit, and it's the standard basically for MIDP development because it's just out there, free, standalone, very small, lots of awards and so on. That's a screenshot. You'll probably notice this phone here is the phone we were using earlier, and it actually used the Wireless Toolkit, except for you didn't see these free grabs here. This is the memory allocation, this is the some stack dumps, and this is the main toolbar. So this is the mobility pack I showed you. Like I said, it's a visual mobile designer, drag and drop. You have a wireless connection wizard, so you can deal with Bluetooth and so on. And it integrates with the toolkit. It's just a shot of the demonstration I gave you earlier. Some resources. So Java.com is the sort of marketing site where you find games, you find utilities and tools for Java. We had lots of third-party interest in that. This particular screenshot was from about a month ago. They were advertising Canon fodder. And there's some URLs there as well. So javagaming.org if you're interested in gaming. Java.sun.com/JTWI is where you find all the mobile development going on. Developpers.com is where you get the tools and podcasts and videocasts and all those sort of great things. And netbeans.org, of course. One other interesting one is blogs.sun.com. You'll probably know what blogs are. A lot of Sun engineers are blogging now. So it's a great place to go and find out really what's happening, the sort of little tips and tricks and inside information. So that's what I wanted to say on Java ME. Did anybody have any questions?